In this video, we are going to solve the equation 4x squared minus 40 times the floor function of x plus 51 equals 0. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. This quadratic equation is actually not really the classic one that we usually do, because here is the floor function on the x term in the middle. By definition, this number is defined by the largest integer that is smaller than or equal to x. So if x is an integer, then it's fine, but if not, then we'll have to go to its previous integer. Sometimes when x is positive, then we may refer that as the integral part. But that would not be the case for negative numbers. For example, if x equals minus pi, so it's around minus 3.14, then after going through the floor function, the output will be minus 4 instead. So we know that by definition, the floor function of the number x lies between x minus 1 and x. And it's possible that this number is exactly equal to x. Now with this range, we can take a look at the range of the whole term, minus 40 times the floor function of x. And it should be between minus 40x and minus 40 times x minus 1. So for our equation, for the given equation, I can say we just add 4x squared and 51 on all parts of this inequality. So for the minimal side, we have 4x squared minus 40x plus 51. While on the maximal side, we have 4x squared minus 40x plus 40 plus 51. And that gives plus 91. And we know that we're given that the expression in the middle is equal to 0. So our inequality actually becomes 0 between two quadratic polynomials. And what we have to do is to solve them separately. The first one being 4x squared minus 40x plus 51 is at most 0. And the second inequality is 4x squared minus 40x plus 91 is larger than 0. Fortunately, both quadratic expressions can be factorized. For the first inequality, we have 2x minus 3 times 2x minus 17, and the product is at most 0. For the second inequality, we have 2x minus 7 times 2x minus 13 is greater than 0. So because we want both inequalities to hold at the same time, for the first one, we have x lying between 3 over 2 and 17 over 2. While for the second inequality, we have x less than 7 over 2, or x is larger than 13 over 2. So combining, we actually have x to be within a very small range. It's either between 3 over 2 and 7 over 2, or it lies between 13 over 2 and 17 over 2. Now from this range, we know that there are very few possibilities for the floor function of x. For the first possible range, since x can be 1.5 or some number between 1.5 and 2, so the floor function of x can also be 1. Of course, it can be 2, or somewhere between 3 and 3.5, so the floor function of x can also be 3. Whereas for the second possible range, x lies between 6.5 and 8.5, so using a similar argument, it can also be either 6, 7, or 8. So we have 6 possible values for the floor function of x. And with this, we can put these values one by one into our given equation and see what would x equal to for each case. Then, if we put this into our original equation, we have 4x squared minus 4t times 1 plus 51 equals 0. But clearly there's no solution because 4x squared plus 11 is always positive. When the floor function equals 2, then from this, we can say x squared equals 29 over 4. So x is either root 29 over 2 or minus root 29 over 2. But of course, we have to reject the negative solution because the floor function of x now has to be equal to 2. And root 29 over 2, all divided by 2, really is about 2 point something, so the floor function of it is indeed equal to 2. Now when the floor function equals 3, we have x squared equal to 69 over 4. So using a similar argument, x is equal to root 69 over 2. We can ignore the negative solution. However, root 69 is larger than 8. So when it's divided by 2, it's larger than 4. So it's not a valid solution. Now, when the floor function equals 6, then x squared equals 189 over 4. So x equals 3 times root 21 over 2. Now root 21 is between 4.5 and 4.6. So when it's multiplied by 3 and divided by 2, it's about 6.7 to 6.8. So it's a valid solution. When the floor function equals 7, x is equal to square root 229 over 2. And because it's about 15 over 2, so again, it's a valid solution. Finally, when the floor function equals 8, x squared, or I should say x is equal to root 279 all divided by 2. Sorry, 269 instead. And this number is between 8 and 8.5 because root 269 is between 16 and 17. So again, it's a valid solution. So altogether, x can be either root 29 over 2, 3 root 21 over 2, root 229 over 2, and root 269 over 2. So this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.